Physics Part 14 Pythagoras Theorem. For a right-angled triangle as shown in the figure bottom, h square is equal to a square plus a square. Also for a right-angled triangle, sin theta is equal to theta over h, cos theta is equal to a over h, and tan theta is equal to o over a. This is how it will move along, and then we'll get along the mathematical justification for the same. The next chapter is that of measurement techniques. This account, this book, this tutorial is about experimental rather than purely theoretical physics. The idea you will meet in it called the tested experiments. Because of this, it is important that you should have an informed and confident approach to work in the laboratory. You should be able to make a sensible choice of what instruments to use to measure a particular physical quantity. You should also be aware of the sources of error and uncertainty in your experimental work. This chapter looks at some of the measurement techniques available in your school or college physics laboratory. You will also learn how errors and uncertainties in your reading affect the final value of the quantity to be measured. 2.1 Measurements. At the end of section 2.1, you should be able to use techniques for the measurement of length, volume, angle, mass, time, temperature, and electrical quantities to all appropriate ranges of magnitude. In particular, you should be able to measure lengths using a ruler, vernier scale, and micrometer. Measure weight and hence mass using spring and lever balances. Measure an angle using a protractor. Measure time intervals using clocks, stopwatches, and the calibrated time base of the cathode ray oscilloscope (CRO). Measure temperature using a thermometer as a sensor. Use ammeters and voltmeters with appropriate scales. Use a galvanometer in null methods. Use a cathode ray oscillator oscilloscope (CRO). Use a calibrated Hall probe. Use both analog scales and the digital displays. Use calibration curves. All experiments designed to obtain a quantitative results for a physical quantity involve measurements. These measurements must be of some combination of the base quantity, length, mass, time, temperature, and current. To complete the list, we should include quantity of substance and the luminous intensity, but these are not counted in experimental work in our part of the course. In the following sections, we shall look at the methods available for measuring the base quantities in a school or college laboratory. By understanding the principles of available methods, we shall be able to make an informed decision about the choice of a particular technique. Our figure shows students doing an experiment in a physics laboratory. Well, we shall be able to make an informed decision about the choice of a particular technique with respect to making the experiment as precise and reproducible as possible and avoiding sources of systematic error. All of the quantities, the effective choice will be limited by what instruments are available in your laboratory. However, in one type of the exam question on planning and design, you may be asked to devise an experiment and draw on your theoretical rather than practical knowledge of the various types of apparatus. Well, the students of this course generally assume that the calibration of the instruments they use is correct. However, it is worth thinking about how to compare the calibration of one instrument against another. Even if this is a compare, even if this is a check you will very seldom make. In a planning design question, you might be asked to suggest a method of calibration. Generally, it is easy to compare the calibration of different instruments.